Hi, welcome you all to iterative improvement algorithm session. Here, this algorithm is building an optimal solution by starting with some feasible solution. This feasible solution will initialize with assuming some values to the given variables. When you are taking that solution by assumption that should satisfy all the constraints of the given problem, this process has to be repeated until there is no further improvement in the solution which found in this previous step. So here we have to find the feasible solution by applying the iteration process until getting there is no improvement. For that, change the current feasible solution to the next feasible solution with an improved value of the objective function. Here the objective function will be available with some variables like this. So when you are substituting the values for this variables, we have to get the improved solution. Until that, we have to keep on change the current feasible solution by supplying improved values. So here that solution to be stopped whenever there is no improvement in the objective function value. Then that algorithm returns the last feasible solution as an optimal solution for this given problem statement. The feasible solutions are solutions which should satisfy the constraints of the given problem, and the objective function is here that will be maximization function or minimization function. The applications here we can use in the numerical methods to find root of the given problem, or finding the maximum or minimum of the profit or loss. Okay, so based upon that, here we are going to discuss the linear programming is one of the iterative improvement algorithm. This can be applied to maximization problem or minimization problem. Maximization in the sense the user or developer or in manufacturing industry, the owner wants to maximize his benefits in the sense profit. Okay, when he is manufacturing a product, he wants to increase the number of products from the given raw materials. Okay, so here the minimization is representing the minimizing the loss, so minimizing the raw materials and maximizing the productions. Okay, that is the meaning, but mostly this linear programming will be applied to solve the maximization problem. The linear in the sense which is representing the variables in equation, the degree will be 1. For example, you see we will have the maximization function like x1 plus 3 x2 plus 4 x3 like this. So here the degree of the equation is 1, so that's why it is called a linear equation. Suppose if you are having 4x square plus 3x cube, then it is not a linear equation, it is non-linear equation. Okay, so here in this problem we are going to deal with only linear equations, so linear programming. Here the objective function is defined generally with the maximization or minimization z equal to c1 x1 plus c2 x2 plus cn etc cn xn. So here, for example, you take the manufacturing industry. For example, you are going to design, you are going to manufacturing a paper. Okay, so you are going to paper notebooks. Okay, right. So here when you are manufacturing like this, you need the raw materials like wood, right, then water and some chemicals. Okay, so then using this raw materials, you are going to feed into the some machine, right. I don't know the process, actual process. We are feeding into the machine, then this machine will generate the, I mean, boil or something doing process. Okay, after that process we will get the number of papers. Okay, so here when you are feeding the some quantities, right, 10 kg here, 5 liter, right here 2 liters. Okay, so like that you see x1 is 10 plus 5 x2 plus to x3. So when you are supplying this one, you have to get the papers, right, less than or equal to some number of papers, for example 100 pages. So like that we will define the equation. So here when you are trying to give this combination, okay, this combination of the materials, you want to maximize the number of pages, maximizing the number of pages. So here the we are trying to maximize the objectives. Okay, our objective is here improve the number of pages production. Okay, that is the thing. Subject to here, you can change the combination here sometimes, okay, based upon this constraints. So right, this combination may be changed, right? So less than or equal to, or equal to or greater than or equal to some quantity, so this value. Okay, that is the thing. So whenever we are trying to doing the manufacturing, so at that time that maximization function, right, to be satisfied this conditions. Okay, right, that is the thing. So here x is decision variable, b is here constraint level, and c is the coefficient of this maximization function, and a is the coefficient of constraints. So this is generalized form of the linear programming. So based upon that, we can solve the simplex method, which is solving the linear programming to maximize our uh, profits or benefits and minimizing the loss. Thanks for watching. We will see the simplex method in next video.